In Python, a set is an object that stores items of data. Now, you've worked with different types of objects that store items of data. For example, you've worked with lists and tuples, and you've worked with dictionaries. Sets have some unique properties, however. One of them, the most notable, is that all of the elements in a set must be unique. You can't have duplicated items stored in a set. Also, another characteristic of sets is that the items stored in a set are unordered. There's no sequence to the items that are stored in a set, so you can't sort the items in a set to get them in any particular order. And it's worth mentioning that the elements, the items that you store in a set, can be of different data types. Now, in all of the examples that we're going to look at, we're simply going to store items of the same data type. We're simply going to create a set that holds strings, or a set that holds integers or floating point numbers. But it doesn't have to be that way. There's no such restriction. You can store any variety of items in a set. So if your programming problem that you're working on requires such an approach, then you can take that approach. Okay, well, let's look at some examples of how you create a set and store items in a set. The first technique that we'll look at is creating an empty set and then using the add method to add items to the set. So I'm going to type a statement here that will create an empty set, and it will assign a reference to that set to a variable named mySet. So that's what happened just now. We now have an empty set created in memory, and this variable mySet references that object. So there's nothing in the set. I can prove that by typing the name mySet and pressing the enter key, and we get this notation indicating that it's just an empty set. So let's add some things to it. Let's add the numbers 1, 2, 3, and 4 to this set. Well, we have to do that one element at a time. mySet.add, and then we'll add the number 1. mySet.add, and then we'll add the number 2. mySet.add, and we'll add the number 3. We'll add one more, mySet.add, and we'll add the number 4. So now, if I just type mySet, we see the results. We see that we get the contents of the set 1, 2, 3, and 4. In the previous example, we created an empty set, and then we added items to the set. You can also initialize a set when you create it with the set function. But there's something you need to keep in mind about that. The set function only accepts one argument. You can't pass multiple arguments to the set function. And this can be a problem because it's very easy to assume that you can do something like this. Let's say that we want to create the same set that we had before, a set containing the elements 1, 2, 3, and 4. You might be tempted to do this. You might be tempted to pass the arguments 1, 2, 3, 4 to the set function, but look, watch and see what happens when we try to execute that. So we get an exception raised, and the exception tells us set expected at most 1 argument, but it got 4. So we can still initialize the set with multiple values, but we have to do something special. We have to package those up in something like a list. So I'm going to try to do this again, but I'm going to pass as an argument a list containing the values 1, 2, 3, 4. So when we execute that, it works. Now, why did this work when the first attempt did not work? In the first attempt, I was passing 4 arguments, but in the second attempt, I'm passing only 1 argument a list. Now the list happens to contain 4 elements, but the list itself is just one argument. So if I look at the contents of the set, I see now that it does in fact contain 4 elements. You should also keep in mind how the set function behaves when you pass a string as an argument. If you pass a string as an argument to the set function, the string will be broken up into its individual characters, and those characters will become the elements of the set. For example, suppose we do this. We pass the string containing these letters A, B, C, D, E, F. Okay, and then if we look at the contents of the set, we see that the set contains all of these elements. These are the individual characters of the string, so the string was broken up. And also, this example illustrates the unordered nature of a set. Notice that the order of the characters in the string is not the same as the order that we see them displayed when we print the contents of the set. Just reinforces the notion that a set is unordered. Now, you'll recall I mentioned at the beginning of the video that all of the items contained in a set must be unique. You cannot have duplicate items. So let's try something else. Let's create a set, and we're going to pass a string as an argument to the set function, and we're going to pass a string that has some duplicated items. So here we have the letter C that's repeated a number of times, and you'll notice that there is no error that occurs. We don't get an exception. So let's look at the contents of the set. And you'll notice that the letter C, even though we sent something to the set function that we would think would create multiple instances of the letter C, it really only occurs once. Now, if you want to initialize a set with strings, where each element is a string that contains multiple characters, then you'll have to do something like we did here in this previous example, where we passed a list of numbers. You would pass a list of strings. For example, let's say that we want to have some names. We want to have a set that contains some names, so we would have to package those names up in a list. So we're going to have a list that has Chris, Katie, John, and one more. Let's have Phil. So in this statement, we passed this list where each element of the list was a string. If we look at the set, here we see the set contains those strings as elements. Okay, well, let's revisit for just a moment the add method, which we demonstrated earlier. The add method allows you to add an element to an existing set. Here I have created this set of names, and let's say that I want to add another name to the list. I want to add Megan to the list, and I'll just print the contents of the list to show you that Megan was indeed added. So the add method, when you pass a string argument to the add method, it does in fact add the entire string as an element to the list. It does not break the string down into its individual characters like the set function does when you're creating a set. Now, the add method will not allow you to add a duplicate item to a set. And just to show you what happens when you try to do that, let's try to add John to the set again. And you can see that it did not raise an exception. There was no error that occurred, but at the same time, John was not added again to the set. So attempting to duplicate an item, to add an item to a set when that item already exists, it just simply won't happen. There will be no exceptions raised, but the set will not allow you to add that item again. If you want to remove an element from a set, there are a couple of different methods for that. One of them is the remove method, and I'll demonstrate that by removing John from our set. You simply pass the value of the element as an argument to the remove method, and you can see that John is no longer in the set. Now, if you try to use the remove method to remove an item that is not in the set, you'll get an exception. For example, if I try to remove John again, we get an exception because John's not in the list. Now, there is another method, the discard method, that removes items from a list, but if the specified item is not in the list, it does not raise an exception. To demonstrate, I'll call the discard method, and we're going to discard Phil from the list this time. Okay, we'll look at the list. You can see that Phil is no longer there. If we try to discard him again, no error was raised, no exception was raised, but at the same time it didn't affect the contents of the set. Now, in your textbook, you'll see discussions of some other methods that operate on sets. For example, you'll see the update method, which allows you to add multiple items at once to a set, or you can merge one set into another set, or you can merge a list into a set, that kind of thing. You'll also see a discussion of the clear method, which clears the contents of a set. Your textbook shows an example of using a for loop to iterate over the items that are in a set. Keep in mind that sets are unordered, but you can use the for loop to actually access each element in a set. Also, you'll see examples of using the in operator and using not in to determine whether an item is in a set or is not in a set. So we won't cover those in this video, but I would encourage you to look at that in the textbook. Now, the remainder of the video is going to show examples of how Python supports the common mathematical operations that are associated with sets. Specifically, you can find the union of two sets, you can find the intersection of two sets, you can find the difference of two sets, you can find the symmetric difference of two sets, and then you can also find subsets and supersets. So let's look at some brief examples of each of those. The union of two sets is a set that contains all of the elements of both sets. And in Python, you can find the union of two sets by using the union method. There's also an operator that will give you the union of two sets. So to demonstrate this, I've created two sets in memory, set 1 and set 2. And you can see that these contain letters of the alphabet. Set 1 contains the letters A, B, C, and D. And set 2 contains the letters C, D, E, and F. Now, I can get the union of these two sets. One way that I can do that is, let's say that I want to create a third set called set 3, and I'll assign it the result of the union of these two sets. So I'll say set 1 dot union. Union is a method, and I'll pass as an argument set 2. And then we'll look at set 3, and this set 3, contains the union of those two sets. Now you'll notice that there, between set 1 and set 2, there are some duplicated items. C and D appear in both sets, and when we got the union of those two sets, of course you can't have duplicate elements in a set, so those items were were only created once in the resulting set. So we have A, B, C, D, E, and F in the resulting set. Now, I mentioned that there's an operator that you can use instead of calling the union method. The operator is the vertical bar, or it's also called the pipe symbol or the broken bar. But anyway, that character on your keyboard is an operator that returns the union of two sets. Let me create another set. I'll call it set 4 equal set 1, and then here's the union operator set 2, and we'll display the contents of set 4, and we see that we indeed have the union of sets 1 and 2. We have A, B, C, D, E, and F. The intersection of two sets is a set that contains only the elements that are found in both of the sets. And in Python, you can use the intersection method or the intersection operator to get the intersection of two sets. And to demonstrate that, I've created, once again, the same two sets. Set 1, which contains A, B, C, and D as its elements, those characters, and set 2 contains the characters C, D, E, and F. So if we were to get the intersection of sets 1 and 2, we would get only the elements that are found in both of these sets, and that would be the characters C and D. So let's try that. We're going to call it set 3, and set 3 is going to be the intersection. So we say set 1 dot intersection. Intersection is a method, and we're going to pass as an argument set 2. And let's look at the contents of set 3. So as we predicted, we get only the elements C and D. Now the intersection operator is the ampersand, so it might be more convenient for you to do something like this. We'll say set 4 equal set 1 intersection set 2, and then we will look at set 4 and we get the same results. When you get the difference between two sets, then you get a set that contains the elements that are in one of the sets but not in the other. For example, here I have set 1 and set 2. These are the same sets we've been working with. Set 1 contains A, B, C, and D. Set 2 contains C, D, E, and F. And if we were to get the difference of set 1 and set 2, then we would get the elements A and B, because those are the elements that appear in set 1 but do not appear in set 2. Now there's a method called a difference that you can call to get the difference between one set and another. So I'll demonstrate that. I'll say set 3 equal set 1 dot difference, pass set 2 as an argument. And then let's look at the contents of set 3, and we get A and B. You can also use the subtraction operator, the minus sign, to get the difference from between one set and another. So this time I'm going to say set 4 equal, and we'll reverse the operation. We'll say set 2 minus set 1. And this operation should give us the elements E and F, because those are the elements of set 2 that do not appear in set 1. Look at set 4, and sure enough, it contains the elements E and F. The symmetric difference of two sets is a set that contains all of the elements that are in one of the sets but not in both. In other words, it's the elements that are not shared between the two sets. And to demonstrate that, I'll once again use the same sets that we've been using, set 1 and set 2. And there's a set method called symmetric underbar difference that you can call to get the symmetric difference. And I'll create a set named set 3, and I'll assign it the symmetric difference between the symmetric difference of sets 1 and set 2. So we just say set 1 dot symmetric difference, and we pass set 2 as an argument. Now Set 3 should contain the elements that are not shared between set 1 and set 2. So that's going to be A and B, and E and F. So let's take a look at set 3, A, B, E, and F. So you can also use the caret operator to do this, which is probably more convenient than the name of the method. It's easy to misspell this method name, so we could do this again. I'll say set 4 equal set 1, and then the caret sign and set 2. And we'll look at set 4, and it contains A, B, E, and F. You can determine whether one set is a subset of another set, or whether one set is a superset of another. To demonstrate this, I have these two sets. These are slightly different than the sets we've been looking at. Set 1 contains the characters A, B, C, and D, and set 2 only contains the characters A and B. So you can see that set 2 is a subset of set 1, and set 1 is a superset of set 2. In Python code, we can test sets for these relationships using the is subset method and the is superset method. So let's just type in a Boolean expression. Those two methods return true or false, by the way. So let me create a Boolean expression. We want to determine whether set 2 is a subset of set 1. So we're going to type is subset of set 1. And this gives us the value true. So this Boolean expression, set2 dot is subset set 1, you read this to say is set 2 a subset of set 1, and it will return true or false. There is a is superset method, so I'm going to create another Boolean expression, set1 dot is superset of set 2, and that returns true because set 1 is a superset of set 2. So you could use these expressions in an if statement, for example, an if statement or a loop or any other place where you're going to use a true or a false value. Now you can also use operators instead of these methods. For example, there is the greater than or equal operator to determine whether one set is a superset of another set. And here we're determining whether set 1 is a superset of set 2. And it's true. Set 1 is a superset of set 2. And if we want to determine whether one set is a subset, we can use the less than or equal operator. And in this example, we're determining whether set 2 is a subset of set 1. So we're saying set 2 less than or equal to set 1, and that returns true.